I might be deep into vintage computers and retro network gear, but when it comes to my day-to-day work, I'm all about efficiency and modern tech. A few months back I gave my NAS systems a major refresh and consolidation. The result, I slashed my constant IT-related power usage from 900 watts to just 700. Not bad, right? And if I rewind 2 years, when my setup was still eating 1.5 kilowatts, yeah, that's a major difference. Now, as I mentioned in my last behind the scenes video, my Cisco switches and access points alone were pulling a solid 290 watts and still didn't give me enough 10 gigabit ports for my growing demands. So today we're diving into how I finally swapped out that aging Cisco gear for some sleek modern Ubiquiti hardware and whether I managed to shave off yet another 200 watts in the process.
Let's talk about legacy network technology. I'm the Vintage Collector and these are my stories.
So what you're looking at is the connectivity rack. Right now it holds a 24-port Cisco 3750E PoE switch from 2010, a couple of routers and some other gear. Since it's a PoE switch, it powers 3 LAP1142N access points, also from 2010. That switch is cross-connected via 2 stack cables to another Cisco 48-port switch in my other rack. Same model line, but from 2008. All this gear, switches and access points, is 15 to 17 years old, which means, yes, it's vintage. And no, it's not exactly power efficient. As you can see, the current draw is 290 watts total. About 250 watts go into the switches, around 33 watts to the access points, and the rest to other PoE devices, which will come back in a minute.
Come on, what's all the fuss? Just buy new gear and save some power.
Of course, but it's not that simple. There were quite a few factors involved and it led me onto a days-long journey through spec sheets and power charts. Why? Because I had very specific requirements. A permanent power reduction of at least 200 watts, at least one 24-port switch in each rack with a minimum of 16 PoE ports. Enough 10G ports for my NAS, video workstations and future expandability. CLI and API access, ideally with web and app management, SNMP for legacy. Support for .1Q VLANs, LACP and spanning tree. And last but not least, stay within a budget of 2000 Swiss francs. So I started comparing Cisco Meraki, which both I know professionally, HP Aruba, which we use at work too, of which I even had some actual test units at hand. I also looked into Ubiquiti, Mikrotik, TP-Link and others. I built a pretty exhaustive list, features, required accessories, prices and most importantly the power consumption from each vendor's datasheet. Now remember those two PoE consumers. This is actually HP Aruba access points which I had deployed alongside the Cisco's. They use less than half the power of the Cisco access points. I hadn't planned to include APs in my upgrade, but at that point, why keep burning 40 watts when I could cut that in half and upgrade to Wi-Fi 6? From there, I worked through multiple scenarios, combining different gear. In the end, I picked Ubiquiti, not because the others were bad, but because it hit the right balance for me. Good value, solid feature set, and it's just comfortable to use. Also, I could run my own device controller locally without needing to rely on cloud management, something not every vendor allows. But even then, I had to ask myself, am I really improving things by replacing 2 switches with 2 others plus adding a third 10G switch? Didn't I want consolidation? Even within Ubiquiti, I narrowed it down to 4 possible setups, some minimal, some more generous with 10G ports. I initially priced everything with Ubiquiti's official accessories, but let me tell you, after 25 years in networking, no-name modules usually work just fine. Of course, there's always a chance of getting a dud, like this DAC cable that caused port flapping, but more on that later. Price-wise, the choice could have been easy: go cheap or settle for a middle ground. But I also needed to factor in power savings. So I ran the numbers, calculated the yearly power savings, the cost offset, and how quickly the investment would pay for itself. Now vendor specs are nice, but often a bit optimistic. Luckily, Ubiquiti's community came through, people started posting real-world power draw data. And while not every device was covered, it was clear that even though access points were rated at 9 watts, the average was closer to 3 to 4 watts. So I created a second power model based on those real-world numbers, much more realistic, and with it a clearer picture for my actual savings.
Alright, we get it. Your TCO math checks out. Now how about showing us that gear already?
Alright, so here it is. 4 Wi-Fi 6 access points, the USW24 PoE with 24 gigabit ports, 16 of which are PoE capable, and the USW Pro aggregation, offering 28 SFP plus ports for 1 and 10G and an extra 4 SFP 28 ports for 25G. While unboxing the gear, I noticed there's very little plastic, mostly cardboard and anti-static foam. The switches come fully loaded, power cables, rack mount brackets, all the screws and even a printed quick start guide. The Pro aggregation switch also came with a surprise, a 1 meter DAC cable I had completely overlooked. Nice touch. Even though it's probably too early for this, I hooked up my amps meter just out of curiosity. It's not very precise and it flaps between 0 and 0.1 amps because it's limited resolution. Still, 0.1 amps at 230 volts gives us about 23 watts. The access points also use minimal plastic packaging. The small parts come in a plastic bag and the quick start guide is sealed in a protective sleeve. The latter feels unnecessary, honestly. And here's a little fun detail. The box includes a cardboard drilling template complete with a tiny built-in spirit level. The template is genuinely helpful, but the spirit level? Cute, yes, but let's be real, you'll use it once, smile at it, and it ends up in a bin. Once I wired up everything, I repeated the still very not precise measurement. This time it showed 0.2 amps or roughly 46 watts. Of course, that's with zero config and no actual traffic. Once the transceivers are seated and the network's live, the numbers will shift, but still, it's a decent early snapshot. If you're already familiar with Ubiquiti, you might have noticed something missing. I didn't mention or get a cloud key. The cloud key is Ubiquiti's hardware controller that connects to your local network and provides the management interface for UniFi gear. None of the UniFi devices has a built-in configuration web UI, so you do need some form of controller. But there's the nice part. Ubiquiti also offers a software version of the UniFi network controller that runs on Windows or Linux. So as mentioned earlier, you're not tied to the cloud. You can keep all your logs and config data local. And no, you don't need the hardware-based cloud key either. A virtual machine works just fine as long as you have somewhere to host it. In my case, I wanted to run it on one of my Synology NAS servers. As a callback to a previous episode where I consolidated my NAS setup, I mentioned that I upgraded the Synology rack station to 32 gigs of RAM. Exactly to support a use case like this. Even though I've got a VMware cluster, I deliberately wanted to keep the UniFi controller more standalone. That way I can shut down some of the VM nodes occasionally to save power, while the Synology, which only sips about 60 watts, stays online 24/7. To run VMs on the Synology, you need to install the virtual machine manager. That's a bit beyond the scope of this video, but for completeness, besides enabling OpenVSwitch, I also had to deal with LACP. My NAS was configured to use all 4 1 gig interfaces in an LACP bundle, so I had to switch it over to use the balanced TCP algorithm. With that sorted, I spun up a new VM and installed Ubuntu. Now, to get the UniFi network controller up and running, you have two options. Do it manually, the hard way, or use a community-developed script that handles everything for you. Spoiler, use the script, it's super straightforward. Thanks to that, my UniFi controller was up and running within minutes. Well, almost. It did complain about an invalid TLS certificate. But again, the same developer provides another helper script that works with certbot to fetch a proper Let's Encrypt certificate. That's where I hit the small issue. The documentation for the certbot integration could be a bit better. I had to dig through various sources to figure out exactly which parameters go into the acmedDNS.conf and how to properly format the required JSON file. But eventually I got it all working, including the integration with my acmedDNS setup, and ended up with a valid, trusted certificate. When logging in for the first time, you'll be asked to create an account with Ubiquiti Online. So even so all configuration data is managed locally, the login procedure including multi-factor authentication relies on a global user account. That's because it allows you to integrate with UniFi Online also for the app-based remote control from outside your network if you want to do so. But if you don't want that, you can also disable this default behavior for a truly isolated management experience. As soon as I logged into my UniFi network server, it started to automatically discover all my devices. You have to go through a so-called adoption process which pairs the devices with the network server. This will also update them to the latest firmware version. You can have your devices being run with DHCP addressing if you want. Personally, I prefer to assign static addresses to infrastructure devices, which also has the added benefit that they can be managed with third-party software, for example for SNMP monitoring, just as I enabled it here. Don't forget to also configure the SNMP access in the global settings. I then adopted all my existing VLANs. Of course, a traditional Cisco switch would offer way more functionalities, but believe me, you won't need many of that in many networks. Still, Ubiquiti has everything I need, from multicast DNS auto-discovery, IGMP snooping, which may be needed for applications like IPTV, the aforementioned spanning tree protocol for loop protection, and many more. There was only one limitation I ran into. Obviously, any VLAN IDs above 4009, even though technically up to 4096 are supported, cannot be configured. Pity me, as I indeed had a few in that range, so I had to renumber them. No big deal, but still an annoyance. One can also define port profiles with common settings, which can then be easily applied as templates to different ports. I'll be definitely using that feature to define a common denominator for my network ports. As for the Wi-Fi, it works in a similar fashion, where you define your various SSIDs and their characteristics globally. This includes the ability to define if those will be broadcast on all access points simultaneously, only on specific ones, including a defined group of devices. I won't make things more complex than necessary. With 4 access points in total, it's anyway my intent to broadcast the SSIDs everywhere. One neat feature which definitely helps for optimal deployment is the inner space. This allows you to upload floor plans to place the access points into. By drawing the walls and defining their characteristics, inner space will automatically update the coverage area. Not necessarily something I need, as when we built our house many years ago, I had planned the Ethernet outlets accordingly to support optimal placement of the access points. Still, one neat feature that UniFi server supports is to run the channel optimization on a daily basis for adjusting the access points for band collisions and signal strength. That was definitely something that was more cumbersome to configure in the Cisco world. Finally, it was time to swap out the old devices. I started by shifting the existing gear around to make space and built a new network in parallel, minimizing disruption as much as possible apart from the inevitable rewiring chaos. And my wife, a formidable downtime detector, proudly confirmed she didn't notice a thing. Perfect. At this stage, I began reconfiguring selected ports to become LACP link aggregation bundles, allowing me to connect my NAS servers with multiple ports. 4x1 gigabit for my older NAS, now repurposed as a backup target, and twice 10 gigabits for each of my newer NAS systems.
But that's only 6, you could have easily gone with the 8-port switch.
Sure, but I also need 10G links for my workstations. That would have maxed it out right away, and even though it might seem silly to waste precious SFP plus slots on RJ45 1GB modules right now, I'm confident I'll have more 10G capable gear in the future. When that time comes, swapping those modules will be easy. Plus, this setup gives me full flexibility, mixing 1 and 10G connections across RJ45, twin-ax DAC and fiber optic modules as needed. Though fiber will only be a temporary solution, as I plan to transition everything to DAC cables to further reduce power consumption. We'll get into that in just a moment when we go through the final optimization steps. Of course, I also encountered some issues, for example this red wire here, which leads into the inverter. Although I'm using RJ45 SFP modules on the Pro aggregation switch, it can only negotiate to a minimum speed of 1 gigabit. And apparently the inverter has a 100 megabits interface only, so it wouldn't sync, and thus I can't hook it up to the lower switch, which is closer in distance. But the cable was too short to reach the other switch, so I had to temporarily use an RJ45 coupler to use another cable to extend it into the second rack. I'll have to dedicate some time later again to swap the cable, which unfortunately has a proprietary plug on one end. The other issue I ran into was related to those third-party accessories I mentioned earlier. Turns out one of the twin-ax DAC cables wasn't quite right, it caused port flapping. I noticed this on one of my NAS servers where the MCE0 interface kept going up and down. Digging into it with ifconfig, I saw that the DAC module wasn't even recognized as a 10G adapter, just as a 1 gigabits one. Swapping in another cable solved the problem. The port was correctly detected as 10G, the flapping stopped, and the LACP bundle finally came up cleanly. So yeah, keep that in mind. Stuff like this can happen with no-name modules, especially when you're, like me, ordering straight off AliExpress. I did it deliberately to save some money, and to be fair, my experience over the years has been mostly good. But you can expect the occasional dud. Vendor-branded modules usually come with better quality assurance, which can justify the higher price. If you're not the gambling type, third-party branded modules are still a solid, affordable alternative. And if you're okay taking the occasional risk for an even lower price, no-name modules are usually just fine, just order an extra 1 or 2 as spares and you'll be prepared. So beyond all the technological uplift and merits, what was the actual outcome on the power saving front? Let's rewind to my last optimization round when I shaved off around 200 watts of permanent IT-driven power draw. Here's a report from my energy supplier dated January 2025, and it shows I used about 100 kilowatt hours less than compared to January 2024. Now, a constant 200 watt reduction should translate to about 144 kilowatt hours a month. But it's not a straight line, because we're dealing with both permanent load and dynamic load. In my case, that includes things like the heat pump, which is temperature driven. It consumes more when it's colder and less when it's milder, so it fluctuates seasonally. Still, when looking at the broader picture, including data from 2023 and 2022, we clearly see a downwards trend thanks to all those little and not so little power-saving actions over the past years. Altogether, I've cut down my monthly consumption by around 1200 kilowatt hours. That's huge. Also, I specifically chose January for comparison because, despite having photovoltaics on the roof, January typically brings zero solar production. So this isn't offset energy, it's energy I had to actually buy.
But doesn't that mean your amortization math is wrong because of the free solar energy?
Not really. The investment pays off either way. If it's reducing my grid power consumption, that's great. That's money saved. If it's offsetting solar energy usage, that's protecting the ROI from my PV system investment. So from a financial standpoint, it balances out. It's neutral in that regard.
Alright, but did you manage to cut it down to 500 watts in the end?
Almost. Here's the chart, and you see from the baseline power usage of my last optimization round sitting just above 700 watts, generally stable around 720 watts. There's a noticeable spike during the transition where both the old and the new switches were running in parallel. Then comes the big drop when I finally shut down the old gear. After that, my smart meter consistently reported about 560 watts, so that's a solid 160 watt reduction right here. If we zoom in a little further, you'll notice some smaller dips in power usage too. Those came from incremental optimizations. I had a bunch of small devices still powered by individual 5-volt power bricks, and when you have a lot of those, the parasitic losses add up. So I started migrating those to PoE. Now, none of them were PoE ready out of the box, so I used PoE splitters. Those came in all shapes and sizes like this bulky unit here. But newer ones are much more compact like these. Just powering 4 of those devices via PoE instead of wall bricks brought the draw down from around 20 to about 11 watts. Then there's the access points. The UniFi ones draw about 16 watts total compared to the 30 watts of the old Ciscos. Plus another 8 watts saved for the 2 Aruba units I was using before. And it's yet not over. Every watt counts, and there's still room to squeeze out a few more. Now, during the transition phase, I had to temporarily put some fiber optics in place. Cool, yes. Efficient, not quite. From a power perspective, fiber optics aren't great, especially on short distances where they offer no real advantage over copper other than looking cooler in the rack. A typical optical module, whether it's a short range or a long range, can easily draw anywhere between 1 to 3.5 watts, and that's not even counting higher bandwidth ones. Compare that to twin-ax DAC cables, which usually come in at 500 milliwatts or less per port depending on length. That's much more efficient. Unfortunately, when I kicked off the upgrade weekend, I didn't have those DAC cables on hand, so I had to roll with 10G optics to get things running. Only after the DACs arrived I could finally swap out all the optics, and that gave me one last nice little dip in power usage, bringing me to a steady state consumption of around 512 watts. And guess what? That lined up almost exactly with my original educated guess. So yeah, mission accomplished. The setup now does everything I wanted, with the power draw right here where I hoped it'd land. You might say I'm a bit too obsessed with power savings, but let's rewind to 2021 before the photovoltaic system was even in place. Back then, I was hitting around 1500 kilowatt hours per month during summer. That's a continuous draw of 2 kilowatts, and 1.5 kilowatts of that was just my RT workload. So investing in solar and optimizing my gear was not only a logical step, it was essential, especially with European energy pricing going bananas after the Ukraine crisis. Now, 2022 is a bit messy in the data. We built the solar mid-year, so the numbers are skewed. But when you factor everything in, here's the rough trend. In 2022 it was 24 megawatt hours. 2023 saw 19.4 megawatt hours after the first IT power optimization. In 2024 it was around 18.6 megawatt hours with smaller tweaks here and there. In 2025 is still counting, but we're trending into the right direction.
I don't know, I was expecting a bigger long-term drop.
Well, I didn't tell you the full story yet. We also ditched our combustion engine car and switched to a battery electric vehicle, and some of the energy savings from my IT actually went straight into charging the car. But even with that shift, I'm close to energy net zero, generating almost as much as I consume, and the latest IT optimizations help maintaining that balance. Bottom line, you can reduce your power usage by going through lifecycle upgrades. Of course, it doesn't make sense to replace every gadget just for the sake of it, but once something reaches the end of its useful life, swapping it for a more efficient option can bring huge benefits. Personally, I haven't sacrificed a single thing, except wasting power. What do you think about all this? Let me know in the comments below. I'm the Vintage Collector, and this was my special behind the scenes story for today. Thanks for watching, and see you again for the usual retro computing shenanigans after a quick 2-week spring break in early May.